A to B process is adiabatic, and for adiabatic process the heat transfer is 0. And B to C, from the graph we can see that the temperature is constant at 60 Kelvin, and it is an isothermal process. So isothermal process, for any process in general, work done is minus P external dV. Reversible process, so pressure of the gas is the same as the external pressure. Ideal gas follows PV equal to nRT. So work is minus nRT, temperature constant, comes out of the integral 1 by V dV. So minus nRT ln V final by V initial. This is the work done. From first law we know that the change in internal energy of a system is equal to the work done on the system plus the heat given to the system. Internal energy is a function only of temperature for ideal gases. So isothermal process, internal energy remains the same. du becomes 0. dq will become equal to minus dw, which is nRT ln Vf by Vi. So V final, we are talking about process B to C. So gas going from state B to state C, nRT ln V3 by V2. So the total heat transferred from A to B to C is 0 plus nRT ln V3 by V2. N is 1 as given in the question. So R, we need to include the temperature at which this isothermal process happens. So according to the diagram it is T2. So T2, 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 T2. Now this is given to be equal to RT2 ln 10. From this we can see that V3 by V2 is 10. In other words, V3 is 10 times of V2. We are asked the value of 2 log V3, which means we need the value of V2. V2 is not evident from the graph, but we can calculate the volume V2 because volume V1 is given from the graph. We can see it is 10 meter cube. A to B is a reversible adiabatic process, and for adiabatic process we know that PV to the power gamma remains constant. PV is nRT, so nRT by V, V gamma is also constant. nR, they become another constant, and we get TV gamma minus 1 to be constant for an adiabatic process. From this, the state at A says that the values are V1 and T1. So V1, T1, gamma. So gamma is Cp by Cv. Cp is given pi by 2r. We know that Cv plus r is Cp. So Cv is Cp minus r, which becomes pi by 2 minus 1, 3 by 2 r. Gamma is the ratio of molar heat capacity of the gas at constant pressure divided by that at the constant volume. So Cp by Cv is 5 by 2 R by 3 by 2 R, 5 by 3. Gamma is 5 by 3. So 5 by 3 minus 1 is 2 by 3. And this remains constant. At the end, when the gas reaches state B, we have the values V2 and T2. So V2, T2, 2 by 3. From this, we also know temperature 1 and temperature 2, which is T1 is 600 Kelvin and T2 is 60 Kelvin. We also know V1. V1 is 10 meter cube. So everything is in SI. So 10 meter cube. Let's first cancel this. We get 6 1s are 6 10s are 60. 10 times V1 is 10. 2 by 3 is V2. 2 by 3. V2 is 10 to the power 3 by 2 times 10 to the power 1. We got the value for V2. V3 is 10 times of V2. So 10, 10, 3 by 2, 10. We got V3. Now we want the value of 2 log V3. 2 log V3 is 2 log V3 is 10 V2 and this whole thing. So 10 to the power 1 plus 3 by 2 plus 1, which is 2 times 1 plus 3 by 2 plus 1. So this will come to 7.